Welcome to Autodesk University. My name is Luke Mihelsik. I'm a technical marketing manager here at Autodesk, and today's class is going to be connecting Inventor to Fusion 360, how to do it and why you want to do it. The session ID, in case you want to make sure that you're in the right class, is going to be IM500052. You can see my Twitter handle there if you'd like to connect on social media. And you can also email me anytime at luke.mihelsik@autodesk.com. So let's jump right into today's presentation. It's going to be broken up into two sections. The first section is going to be just running through the specifics of this new tool inside of Inventor 2022. And then towards the end of today's presentation, I'll be doing a demonstration showing you how to get that data from Inventor over to Fusion 360. So you probably read the class description, and that's why you're here, obviously. But just to refresh you, in case you don't remember exactly what it said, essentially, Inventor 2022 has a brand new piece of tech that is called Send to Fusion. It's located in the Environments tab, in case you haven't found it yet. And what this new tool allows you to do is take Inventor data and send it to Fusion 360 directly. And I know some of you will say, oh, well, we've been able to do that. There's nothing new there. And while we have been able to do that with Desktop Connector and still can, Desktop Connector required quite a bit of setup, and your connector always had to be updated, and it just wasn't the easiest solution. There was a save option. This tool is built right into the UI. It's, again, in Environments, sent to Fusion 360, and it just connects you directly to Fusion. Super simple, super easy for those downstream or the advanced or specific workflows that only perhaps Fusion 360 has that you're interested in checking out. So there are a couple of key learnings that we want to make sure that we cover today, and we're going to hit a couple additional ones, but the four primary ones are sending our data, or connecting our data rather, from Inventor to Fusion 360 for tool path creation. Think machining components, generating G-code, those sorts of things. Next is connecting Inventor data to Fusion 360 for generative design. And if you're in the engineering and design space, generative design, as you probably know, is all the rage right now. You can't go to a conference or go on social media and see something that isn't related to generative design. And Fusion 360 is really leading the way. And what we allow you to do is take your Inventor data and leverage all of that amazing power inside of Fusion with generative design. We'll talk about that. Also is how we connect our Inventor data to Fusion 360 for simulation. And last but definitely not least, because we will talk about a couple other ones, is connecting our Inventor data to Fusion 360 for visualizations. And I chose this one personally because I really like the way Fusion 360 does its visualizations and does its renderings. It's super easy to set up. It's really easy to apply materials. You can render on the cloud. There's all kinds of really great reasons to consider using Fusion 360 to generate some of those visualizations. So let's talk about some caveats, because there always is a few, as with everything. The first one is this only works with Inventor 2022. So if you have an older release of Inventor, you're not going to see this option. Next is this only works with part files. And those of you that know Inventor, you probably know how to make a multi-body part, or you know how to take an assembly and turn it into a multi-body part. So there's ways to get around this, but again, part files only. Next is it requires an update when the geometry changes. And if you're an Inventor user or a Fusion user, you're always kind of used to things being associative and being live and active all the time. This doesn't work that way in this release. What you will need to do is make an update and push that file over. Again, I'll show that during the demo. And then Fusion 360 recognizes there's a new part there and updates the geometry. And then it only goes from Inventor to Fusion 360. It does not go the other way. So a couple of prerequisites, things you want to make sure that are set up before you do this. I had already mentioned this only works with Inventor 2022 or newer, so depending on when you're watching this video, 2022 is the minimum. Next, you obviously need Fusion 360, or whomever you're sending this data to needs Fusion 360 to create and run those downstream workflows. You'll need access to the Fusion 360 project that you're sharing, and you just do that via Fusion Team. And then finally, you have to have an open mind. And I say this because I know how Inventor users are, and I'm one of them. I love Inventor. I've been using it since it was called Rubicon, and whether I've talked to you face-to-face or maybe online or an email or on social, I think Inventor users think Fusion 360 is replacing Inventor, and that couldn't be further from the truth. And the reality is, Rob Cohey answers this question really well. When people say, oh, should I use Inventor or should I use Fusion 360? And his answer is always, well, use both. If you have the product design and manufacturing collection, you actually have access to both of these tools. And then all you need to do is use the right tool at the right time for the best application. If you're doing something with generative design, you kind of have to use Fusion 360. If you're doing something where you require iLogic and some really advanced automation tools to do configurations, obviously you're going to use Inventor because it's really good at that. So just have an open mind and just think about the ways you can leverage these tools working together. So let's jump right in and talk about the first one. And again, I'm going to go through the slides first, and then we'll have a demonstration at the end of the presentation. So the first one is Inventor to Fusion 360 for CAM operations. And this question is going to happen a bunch of times. When to use Inventor and when to use Fusion 360. And when you might want to use Inventor is maybe you make it and you machine it. Perhaps you're a small operation, or maybe you just enjoy doing that. There's no reason to leave Inventor and go to Fusion 360 for CAM operations. And again, you have to have the collection to do this because the collection has Inventor CAM built into it. Yeah, that's a great reason. There's no reason to leave the environment. Just stay in Inventor, run the CAM operations. Maybe you have tons of legacy parts that you've already programmed. If it's not broke, don't fix it. Keep doing what you're doing. There's no reason to change over to Fusion 360 if your process currently works. So when you might want to think about using Send to Fusion. So maybe you make it, but someone else machines it. Maybe you're sending it out to a job shop down the street or around the world. They're using Fusion 360. That's a great way and reason to actually do that because it's a great way to get them the file. Secondly, maybe you're using Inventor Standalone. Inventor Standalone does not have CAM capabilities. So you would need the collection, and you could use the Send to Fusion to actually get that data to someone that has Fusion to then generate the toolpaths. Maybe you're programming brand new parts and you just want to use Fusion 360, maybe because of the user interface, maybe you just like Fusion 360. Perhaps you're interested in some of the advanced things like the advanced machining options with extensions that has launched recently. And then generally speaking across all of these is you're just connecting to outside stakeholders that are already using Fusion 360. Don't send them a step file. Don't send them an unintelligent exported file. You send to Fusion 360 and connect directly to their project. Next is Inventor to Fusion 360 for generative design. And when do you use Inventor and when do you use Fusion 360? And this one's actually a really easy answer. First of all, Inventor does have topology optimization with a tool called Shape Generator. I've used it a handful of times. It's pretty good for what it does, but it is not generative design. And generative design is not inside of Inventor. So if you're looking for generative design, definitely you have to go to Fusion 360. That doesn't mean you have to create the model in Fusion 360. You can create the model in Inventor and then send to Fusion 360 and leverage those workflows there. So when you want to use Fusion 360, there's all kinds of reasons. You can go to the website and check out the section on generative design. But essentially, if you want to do part consolidation, you have an assembly that's really complicated that you want to simplify maybe down to a single component to maybe improve the manufacturing process, speed, time to market, whatever it might be. Maybe you're lightweighting a component. maybe those parts are too heavy, maybe you're trying to optimize and you just want to create a better component that's lighter, but yet still performs based off of the conditions it needs to. And design exploration and cloud solving. If you've seen any presentations on generative design, you can literally get hundreds, if not thousands, of answers that will show you different materials, different machining operations, different safety factors, and it all solves on the cloud. Again, saving local resources and just giving you way more options than you could ever come up with on your own. The next one is Inventor to Fusion 360 for simulation. And so when to use Inventor and when to use Fusion 360. This is very similar to the CAM one. Maybe you simulate it and you're also the person that makes the components or the assembly. It doesn't make sense to leave the Inventor environment. You can use Inventor Nastran again if you have the collection. And you can do all your simulation right there leveraging the Nastran functionality inside of Inventor Nastran. Or perhaps you have a large assembly that you're trying to simulate, and it's not going to make sense to turn that into a multi-body part and kind of figure that out. Just use the simulation inside of Inventor. Has some simulation as well, and some dynamics, but you could also again use Inventor Nastran. Reason why you might want to use Send to Fusion is maybe you design it, but you send it out for simulation. Someone else, maybe a partner, is using Fusion 360 and they can do the simulation for you. Maybe you're doing a single part, single material simulation and you just want to get over to Inventor to do some cloud computing to leverage those options. You can do multi-body part simulation, so you could take an assembly, create a multi-body part, and then send it over. And the user interface and the setup of simulations inside of Fusion 360 just couldn't be any easier. So I would definitely recommend that you check it out. And again, these simulations can all be done on the cloud if you choose to run them that way. Next up is Inventor to Fusion 360 for visualization. And I chose this one kind of personally because I love the visualization tools inside of Fusion 360. So again, that question, when Inventor, when Fusion 360. So again, maybe you make it, you render it. It's just as easy for you to go into Inventor and do a quick rendering. Maybe you're doing Inventor Studio, whatever you're doing. Maybe you have a really large assembly that you're doing a render of, something that just wouldn't make its way into Fusion 360 very easily. Those very large multi-body part from a really large assembly, they're just really difficult to work with when you're using the Send to Fusion. Just stay in Inventor, do the rendering there. So when you might want to send to Fusion 360, so you're looking for some super high quality renderings, maybe the improved material libraries-ish. So especially the wooden materials, and there's a whole host of materials inside of Fusion's material library. They are just so good. And if you've seen anything from a rendering standpoint out of Fusion 360, it's crazy how good they are. The user interface is super simple. It's really easy to set up those renders, and you can render on the cloud. So you can take advantage again of that cloud computing option. And then the next one is Inventor to Fusion 360 for electronics and PCB. And this wasn't in the key learning points, but I want to review it quickly anyway. So whether you realize it or not, Fusion 360 has a pretty in-depth and really robust PCB tools. So when you want to use Inventor, so Inventor has this amazing connection to AutoCAD Electrical. So if you're working with someone using AutoCAD Electrical for schematics and wire diagrams and all the things AutoCAD Electrical is really good at, and you want to take advantage of Inventor, to do that, there's a direct connection, works really well. When you want to send to Fusion 360. So maybe you're building a housing inside of Inventor that PCB needs to fit within. So you can actually use that as like reference geometry and then build the PCB around that particular piece of geometry. So that's a really great reason to do it. And then obviously the development of PCBs inside of Fusion 360 is really robust. So let's jump into some of the workflow demonstrations right now. In this first example, I'd like to show you how to send a component from Inventor to Fusion 360 for perhaps some machine operations. Maybe you want to generate some toolpath. So the Send to Fusion 360 tool is located in the Environments tab. And remember, this is only inside of Inventor 2022. So when you hit the Send to Fusion tool, it will prompt you to make sure that the file is saved. So in case there's any pending saves, it'll prompt you anyways. You're going to hit OK, and then this Fusion 360 interoperability shows up. You can then choose which team you'd like to send it to, and then which project within the team. And again, you'd want to have all this set up ahead of time. And then by default, the file name is the same as it is inside of Inventor. And this is really important when you go to do updates or if you want to send multiple files over to Fusion 360. I'm going to hit Upload New File. And then I'm going to hit Open in Fusion 360. And I have Fusion here in the background. It'll just take a few seconds to prepare that and get that inside of my design space. So if you think about a machining operation, once this is loaded, I can then change from my design to my manufacturing environment, and I could do perhaps maybe some facing, maybe some additive inspection, whatever I want to do with this particular part. That's not the point. It's how this gets here and how it updates. So what I can do is go back into Inventor and make a change. Let's say this hole disappears or one of these holes goes away. This is where the naming is really important. So I'm just going to take this end apart and drag it down. I had a feature there that removed that hole. I'm going to hit Send to Fusion again. And remember, this is where it's different from being associative. So again, team, project is there by default, except it says Upload New Version. And it knows that because that file name already exists. So if I change the name, it'll just be two different files. If I hit Upload New Version and don't change the name, it'll actually update that file. So I will upload a new version, and then back inside of Fusion 360, I get a warning saying it's out of date. I can just right-click and update my external reference. And you can imagine if I had any toolpath creation here, it would just need to be updated and rerun to account for that change in the geometry. And I can actually refresh my panel, and you can see here that it's a new thumbnail of that component with the hole missing. So that's how our update happens, and that's going to be the exact same regardless of what you're going from Inventor to Fusion 360 for. The naming is really critical. So the next thing I want to show you, and this is that trick I talked about where let's say you have an assembly and you want to take this over to Fusion 360 as a part. Those of you that know Inventor, you know that we can actually either create a multi-body part from scratch, just creating our extrusions and all of our features as independent bodies, or I can take an assembly and I can actually just simplify this. And using our simplification tools, I'm going to just use my default model states. I can actually include and exclude components. So it's kind of a nice feature to have here. But the key thing you want to make sure that you do is a new part file. And you want to make sure that it maintains each solid as a solid body. This will then create that multi-body part file that we can then send over to Fusion 360. So I'll hit OK. And what you should end up with is a part file that looks identical to the assembly. So there's the assembly, there's the part file. And I can actually now go over to my environments, send to Fusion 360. There's my prompt for the save. You're going to choose the team, the project location, and I'm just going to, again, leave that file name exactly the same. I'll hit Upload a New File. I will open in Fusion 360. And now if I go over to Fusion, I should have a new file inside of Fusion 360. So now inside of Fusion 360, I have that assembly. Again, it's a multi-body part, so you can see all the individual bodies. You could go over and adjust color and visibility and suppress or unsuppress, whatever you want to do with it inside of Fusion 360. And again, that update works exactly the same. But let's say I want a different version of this. I don't want to change the file name. So back inside of Inventor, I'm actually going to go back to my assembly, and I'm going to create another simplify. And in this one, I want to use a different model state, and I want to do the 4 unit option. So now I have another variation of this. So that's the model state it's going to use. I'm going to do my maintain each solid as a separate body. So again, what I should end up with is a part file that is the new version. I'll save it. And now this time, whenever I go to send to Fusion 360, I can upload a new file, or if I wanted to replace that one, I could actually just name it the exact same thing. You can see a file with the same name exists at this location. A new version will upload to Fusion Team. Back inside of Fusion 360 now, you can see that we are out of date. I can actually go to update my external reference. And there's our updated file. So in this case, I actually have 2 different files in Inventor that I've pushed to Fusion 360 and named them the exact same name. So you do need to keep track of where and how you put things. The last example I'd like to show you is setting up a part inside of Inventor for generative design inside of Fusion 360. And we're going to use this bracket. And right now it's an assembly, so I need to simplify this down to a part file. And at the same time, I'm going to remove all of these features. So I'm going to use that simplify tool again, and I'm going to remove all of those features. I can hit highlight and see that they're all going to disappear. Again, make sure that you maintain each solid as a separate body. That way it will come over into Fusion 360 as individual solids that you can work with. And I should have a super simple version of that bracket. So this first body and this second body are going to be what are called my preserve regions. So these are the 2 mounting points that I need to maintain inside of my generative design study. And what I'm going to do is create an obstacle. So this is where I don't want Fusion 360 to create geometry on either side of this component here. That way it'll work all that geometry in between. So what I can do is I'm going to add a work plane in between there so I can mirror. And I'm just going to add a new sketch on this surface, project that geometry, and I'm going to extrude this. And it really doesn't matter how far it is as long as it actually goes past that in this example. And this is going to be my obstacle. Let me back up. I actually forgot to, let me edit that feature. You want to make sure this is a new solid. So I'm going to turn on new solid. So now I should end up with 4 bodies. And I'm going to do a mirror of solids, create a new solid, this one here, about this plane. So in total, I should have 5 individual bodies. I have my preserve, and my 2 obstacles. And this body here, it doesn't really matter what I'm doing with it. I could suppress it. I could leave it there. It's really not going to make a difference. I'm going to save this before I go over to Fusion 360. Environments, send to Fusion. Give this a new name. And inside of Fusion 360, I should have a part in a few moments. It's actually a rather simplified component. And let's open that up. And I'm not going to walk you through the complete process for setting up a generative design study, but essentially what we did was we created what we needed for the study inside of Inventor first. So we'll switch over to our generative design environment. And one of the very first things you do inside of generative design is you choose what are called preserve regions. So I want to preserve this body and this body, so it's going to keep those and work with them. And then I want to avoid or select obstacles. It needs to work around these two components. So what I end up with is 2 green bodies and 2 red bodies. I could then come in here and tell it that this is a fixed surface. And I could put a force on this top surface. I can switch my units over to pounds, and maybe I want to do 45 pounds on that surface. I could then walk through setting up my materials, my design criteria. I can generate previews of what this might look like and generate those design studies inside of Fusion 360, again, with geometry that I defined inside of Inventor using the Send to Fusion tool. So before we wrap up today's presentation, I do want to talk about what else you can do with Fusion 360 and why you might want to check it out. And I pulled all of this information pretty much directly from the website, so you can go there and check it out yourself. So this is just kind of a hit list of some of the Fusion 360 capabilities, and I'm not going to read through all of them, but when it comes to design and modeling, it does a really great job with surfacing, direct editing, mesh modeling, amazing jobs there. Obviously manufacturing, there's so much stuff inside of the manufacturing environment, everything from 2.5 to 5 axis, turning, mill turning, all kinds of options inside of Fusion 360. Electronics, we talked about this right before the demonstration. Schematic capture, PCB, some e-cooling is available inside of Fusion 360. All the data management tools that are there whenever you're setting up your Fusion team. So really great options inside of Fusion 360 for collaboration and managing your data. Obviously, additive is a really big part of what Fusion 360 is good at. And then, like I mentioned earlier in today's presentation, the Fusion 360 extensions. So these are advanced extensions only inside of Fusion 360 that allow you to do all kinds of really specific high-end machining, managing, nesting, generative design, additive. So you can check those out. Again, I'll have some resources here in a minute. But also, there's things Inventor can do that Fusion 360 can't do. And again, I'm not going to go into all the details of all of them, but there are reasons why you might need to stay in Inventor when you are creating things. So, and I kind of broke this down into 2 sections, the core Inventor capabilities versus Inventor as part of the product design and manufacturing collection. So core capabilities, cable and wire harness, tube and pipe, BIM interoperability with our Revit connection, frame generator, iLogic for automation, content center. Fusion 360 just doesn't have that functionality yet. Inventor as part of PDMC, these are all the things that you get inside of the collection that you just have access to that you can't do inside of Fusion 360. So tolerance analysis, factory planning with factory design utilities, large-scale design collaboration with Navisworks, ultra-high quality rendering and animations with 3ds Max if you like to do those sorts of things, point cloud data management, and obviously our connection with Autodesk Vault. So some resources you might be interested in. You can see all of the product information. So these are the product centers for Inventor, the collection, Fusion 360, and some of the manage tools to actually access those. You can check out the help at knowledge.autodesk.com. And then there is a list of our social media channels if you'd like to connect or have any questions. So what I'd like to do now is open things up to Q&A.